Lesson 5.11, Interpreting Quadratics in Context from Graphs. So in Delta Math, it'll only have one of these questions on here, but to condense the notes, I put a bunch of them on just 2 examples. So we're going to read the problem, and we're going to try to interpret or explain what the graph means. It says, Tamika throws a ball up in the air. The graph below shows the height of the ball h in feet after t seconds. I love quadratic graphs because the shape of them matches exactly what you picture is happening. This is saying, okay, I'm going to throw a ball off the ground. So this would be a height of 0, or throwing it up in the air. Sometimes kicking it, throwing a football, all the good stuff, a rock, throwing it up, and then time's going to be passing. And then the height, it's going to increase until it reaches its maximum height. And then, of course, gravity is going to make it come back to the ground. So our x-axis is our independent variable. It's always going to be some kind of measure of time, because time we cannot change. Then we're measuring something for our y, that's our dependent variable. In this case, we're measuring its height over the time. So let's answer these questions. How long is the ball in the air? So it started here at 0 seconds. It reached its maximum here at 1.5 seconds. And it hits the ground here at 3 seconds. So 3 seconds is how long it was in the air. What is the interval for which the ball's height is increasing? So it's increasing to here. The interval is saying from what to what? From 0 to 1.5. I'm not sure if they have you do it with inequalities or if they do it with brackets around it. I can't remember. How many seconds have gone? Oh, that was increasing. Oop. Okay, and then decreasing would be then from the 1.5 seconds to 3 seconds. I think it's this. This thing x is between 1.5 and 3. Part C, how many seconds have gone by when the ball is at its highest point? So at what time is it at its peak? 1.5 seconds. What is the ball's greatest height? So at 1.5 seconds, it reached a height of 36 feet. What is the meaning of the vertex? Exactly what just happened. It means, I'm going to put at 1.5 seconds, the ball reached its max height of 36 feet. It is a terrible at sign. There we go. All right, number 2. Kalani launches a toy rocket from a platform. The graph below shows the height of the rocket, h in feet after t seconds. So this one's different because we don't see the full parabola. The reason is because it's not a ball off the ground, it's somebody up at a platform. And so the first question says, what was the rocket's initial height? Where did it start when the time was 0? At apparently 108 feet. So Kalani was 108 feet up in the air, which seems very high. How long is it in the air? So we want to see, okay, how long until it hit the ground? 4.5 seconds. What is the interval for which the ball's height is increasing, decreasing? So increasing, it's increasing only here to here, and then it decreases here to the ground. So that would be in x values. 0 is less than x is less than 1.5. Decreasing would be from 1.5 is less than x is less than 4.5. How many seconds have gone by when the ball is at its highest point? That means how long, what time, 1.5 seconds. What is the ball's greatest height? 144 feet. What is the meaning of the vertex? So again, at 1.5 seconds, the rocket reached its max height of 144 feet.